All right, so for the problem with a girl sliding down a slide that is 20 meters long, we're trying to find a case where there's no friction for part A, where we need to find her final velocity. So what we do is we use the work energy theorem, which says that the initial energy is equal to the final energy. And breaking that down, the initial energy she has is the initial kinetic energy and the initial potential, and that should equal the final kinetic energy and the final potential energy. Now, since she's at rest at the beginning, where velocity is equal to 0, we have no kinetic energy at the start, so we only have potential. And finally, where she's at the bottom of the slide where there's no height, she has no potential energy, but all kinetic energy. So we have this potential energy being transformed into the kinetic energy. So it's mgh is equal to 1/2 mv squared. The m's cancel, and you get v at the bottom. Her velocity at the bottom of the slide is the square root of 2gh. And you can go ahead and plug in g and h to get your calculation. Now, where the case is where there is friction, we have the initial energy equal to the final, except we have this change in W term, where this is the energy lost from the beginning. And what it actually is, it's 68% or 0.68 of that initial potential energy she had. So it just changes your equation in that V is equal to 2gh, square root of 2gh times 1 minus 0.68, which will be square root of 2gh times 0.32. Now, if we lose kinetic energy due to thermal energy, where the speed has been reduced by a factor of root 0.32, that makes sense because the speed is less than the case where there's no friction. If there's no friction, she would be going faster. So our answer aligns, and we did it correctly. All right, now for part C is a little trickier. What we're going to have to do is we're going to have to create an inclined plane, and we're rotating this about 30 degrees. So if just to show the 30-degree rotation, we're just going to do this just to keep everything lined up. Okay, and we're going to call this X and we're going to call this Y. All right, so the question is asking, calculate the force of kinetic friction on the girl during her descent. All right, so kinetic friction is going this way, F of K, and this is going in the positive X, and then she has some mass times acceleration going this way, and then she has some component of mg, and this will be mg sine of 30. Okay, and because this is 30 degrees and this is mg sine 30, this x component. So okay, so if we're trying to find the force of kinetic friction, it's going to equal the mass times acceleration in the negative x direction, plus the weight, the component of the weight in the x direction, and that is going to be, sorry, this should be positive. And the way we get this is we say that the sum of the forces in the x direction will be equal to her mass times acceleration, which will basically just be negative x component of the weight in the x hat direction plus f of k. So in the x hat direction, so f of k just ends up equaling this. Okay, so let's see here. And let me see if I did everything correctly. I'm not sure if this is exactly correct. It might actually need to be ma is equal to the weight minus f of k. Yeah, it should be because it should be in the same direction. So yeah, it would actually be ma. The mass times acceleration is equal to wx minus f of k. Okay, so if we're trying to get acceleration in straight line motion is v final minus v initial squared is equal to 2a delta x, where delta x is our 20 meters. So all we do is we say, okay, well, yeah, so it should be minus the weight. Okay. Should be the weight minus f of k. No, it should be, sorry, it should be minus ma. Let's just erase this, sorry. Okay, so this should just basically be f of k will equal wx minus ma. Now, a is going to equal her velocity. Her final velocity is going to be with friction, so it's going to be that square. It's going to be that square root of 0.32 times 2gh squared divided by 2 times 20 meters, which is our delta x, and v0 is 0. And what we do is we will say, okay, well, we plug this in, and what we'll get is we'll get f of k is equal to mg sine 30 minus m times a, where you're going to plug this a in here. And your g is just going to be 9.8, and then that will give you your f of k answer. All right? All right, good luck.